Okay guys, so today we're just going to talk about the first and second index laws and how they work. So basically, if I was going to do this using the law, I would say, okay, so basically I'm just going to take the two powers up the top, so these are the bases. Now, they need to be the same, and they are in this particular case. And then I would take those two powers and I would add them together, so 2 plus 5, which would give me x to the power of 7. And so, okay, fine, I can do that, but why? Why do I get x to the power of 7? Well, it comes down to a couple of different things. So if we have a look at this, x squared is x times x, all right? And then x to the power of 5 is, well, x, so 1x times 2x's times 3x's times 4x's times 5x's. So if x squared is x times x, so in other words, 2x's timesing by themselves, and x to the power of 5 is 1, 2, 3, 4, 5x's timesing by themselves, then if I add all of these up, I've got 1, 2, 3, 4, 5, 6, 7 x's. And of course, that's how we get our answer, that x is to the power of 7. So that's how our first index law works. I suppose when I think about it, this is the thing that's going on behind the scenes when we use this particular thing. We understand that this happens, and so we have this law. If I was to write the law out, I suppose I've seen it written in several ways. So you could go x to the power of a times x to the power of b is equal to x a plus b. Now the reason that we're using these letters is because, of course, we can replace them with any number. So if I had x to the power of 11 times x to the power of 10, for instance, then this method, I would have to write, 21 different x's down here, and it's just not practicable. So if I'm going to do this, it's going to be 11 plus 10, that's a big word, and that's going to give me x to the power of 21. So that's how our first law works. And we will be giving you in class a more formal definition or proof for this because you're going to have to basically explain that back to us. So the second law here, you see I've drawn it in two ways, remembering of course that this line means division, and I've just actually named up and used the division symbol in this particular way. If I was going to do this law, just doing the law, it's going to be x to the power of 5 take away 2, and that's going to give me x to the power of 3. So why did I add here? Well, we can see why we have, but why am I taking here? And once again, it's going to take us to go back to this basics for us to understand what's happening along the way. So we already know that x to the power of 5 is x times x times x times x times x. That's 5, isn't it? Yep, 1, 2, 3, 4, 5. And then we divide that by x times x, which of course is our x squared. Now, this is a pretty important thing to consider, because if I go x divided by x, or if I write it over here, x on x, well, what's that equal? Well, if we go back to a number version, 2 divided by 2, of course, is 1, because 2 goes into 2 once. So x goes into x, of course, once as well. Notice it's a 1. So when we cancel out, we're not actually making 0, we're making 1. I'm going to write it over here. All right, now I can do that again. I can go x cancel x and x, they cancel out. And so that's going to give me 1, because x divided by x is 1. And then what have I got left? Well, I've got an x and an x and an x left. So 1, 2, 3 x's. So 1 times 1 is 1. 1 times x is x. X times x times x, however, I can write as x to the power of 3, or x times by itself 3 times. And we can notice now, we can see how this rule is actually occurring. So that was a very quick look at the first and second index laws. I hope you enjoyed it, and I'll catch you later.